So welcome back students. So in this session we will have the solution of problems for the losses in precious concrete. So in the last session we discussed about the types of losses in precious concrete, and we discussed about the loss due to shrinkage, loss due to creep, loss due to friction, and loss due to slip, and also loss due to relaxation. So now according to the previous session, so we will solve a problem or how to calculate losses because of shrinkage in concrete. So I'll read out the statement of the problem. A concrete beam is pre-stressed by cable carrying a initial pre-stressing force of 300 kilonewton. The cross section area of wire is 300 mm square. Calculate the percentage of loss in stress in the cable due to shrinkage of concrete for post tension and pre-tension beam. And they are given ES, that is modulus of elasticity of steel, is 210 kilonewton per mm square, and the age of concrete is 80. So here we will have the given data first according to the problem statement of the problem. So that is, we will note down the given data first. So they are given the initial pre-stressing force that is Pi is 300 kilonewton. Then this is the first given data. Then second, they are given the cross section area of wires. The cross section area of wires, that is 300 mm square, and you have to find out the percentage of loss for two cases, that is in case if it is post tension and pre-tension system. So this is regarding the given data. So now according to the area of pre-stress and the initial pre-stressing force, we can easily find out the initial stress in wires. So therefore the initial stress in wires, so you can easily find out that the pre-stressing force divided by area of pre-stress. So this is the cross section area of pre-stress is given as 300 mm square, and even the pre-stressing force is given as, the initial pre-stressing force is given as 300 kilonewton. So 300 into 10 is to 3 divided by the area of pre-stress is 300. So we will get the initial pre-stressing force as 1000 mm square. So this is the initial pre-stress provided in the concrete by the cable. So that is 1000 Newton per mm square, that is 1000 Newton per mm square. Now we have to check what is the loss due to shrinkage of concrete in the cables. So this is the initial pre-stress. So what is the loss of pre-stress due to shrinkage of concrete in the cables? So according to the formula what I have discussed in the previous class, I think here, so you can easily find out loss due to shrinkage. So epsilon Cs into Es. So shrinkage strain is epsilon Cs. So they have given the criteria for that condition. If 300 into 10 to minus 6 for pre-tension and 2 into 10 to minus 6 divided by log of T plus 2. This part I have covered in the previous session. You can go back and check. So we will calculate one by one. So now we will calculate. So first case we will calculate for pre-tension. For pre-tension member we will calculate the loss. So for pre-tension, the basic equation for loss is epsilon Cs into ES. It is epsilon CS into ES. Okay. So for pre-tension member, we have to take the value of epsilon CS. So that is shrinkage strain. Shrinkage strain, we have to take the value, the standard value as 300 into 10 to minus 6 into modulus of elasticity of steel is given as here. They have given the modulus of elasticity of steel is 210 kilonewton per mm square. So that is 210 into 10 to 3 to make it in Newton. So we get 63 Newton per mm square. So we got the loss as 63 Newton per mm square. That is in pre-tension system. Okay. So therefore the percentage of loss is equal to, the loss is 63 and the total, the initial pre-stress developed in the concrete is 1000 divided by 1000 into 100. Okay. So it is equal to 6.3%. So there is a loss of how much? There is a loss of 6.3%. Understood? Now we will go for post-tension system. Okay. Now we will go for post-tension system. Okay. So case 2 for post-tension. Okay. So again the equation remains same. Loss is equal to epsilon CS into ES. But for post-tension system, the value of epsilon CS is taken as 200 into 10 to minus 6 divided by log of T plus 2. So where T is nothing but age of concrete. T is age of concrete. Okay. So here T is given as 8 days. Here T is given as 8 days. Okay. So now we calculate epsilon CS first. So that is 200 into 10 to 6 divided by log of 10. T is 8 plus 2. So we will get the value of that is 200 into 10 to minus 6. Okay. So after getting epsilon CS, you can calculate loss is equal to epsilon CS is 200 into 10 to minus 6. We have got here, and the modulus of elasticity of steel is given as 210 into 10 to 3. So we get a loss of 42 Newton per mm square. So पोस्ट टेंशन में कितना लॉस हो रहा है? There is a loss of 42 Newton per mm square. So therefore percentage of loss is equal to 42 is the loss and the initial pre-stress is 1000 into 100. So we got the loss is 4.2%. Okay. So understood. So if we use the system of pre-stressing, that is in case if it is pre-tension and if it is post-tension. So in case of post-tension the loss is 4.2 and if it is pre-tension the loss is 6.3. So this is regarding the loss in pre-stress due to shrinkage of concrete. Okay. So we will solve one more problem. Okay. To calculate loss of stress in steel due to creep of concrete. The previous problem we solved, that is loss of stress in steel due to shrinkage of concrete. So now we will solve one more problem in this session to check what is the loss of stress in steel due to creep of concrete. Okay. So regarding that I have discussed in the previous session, and I have discussed the equations, okay, and how the creep loss will take place in pre-stress concrete. Okay. So now we will solve a problem based on the previous discussion. We will have a small problem to calculate the stress, loss of stress in steel due to creep of concrete. Okay. So I will read out the statement here. So they are given a concrete beam of rectangular cross section 100 mm by 300 mm, pre-stressed by 5 wires of 7 mm dia. located at eccentricity E is equal to 50 mm. Okay. The initial stress in wires is 1200 Newton per mm square. Calculate the loss of stress in steel due to creep of concrete using ultimate creep strain and creep coefficient method. Okay. So here they have given beam size and the area of the cable, and the important is the initial pre-stress in the concrete is 1200 Newton per mm square. So because of creep of concrete, what is the loss of stress in steel? Means initially is 1200 and after loss, okay, what is the value and what is the final pre-stress in the concrete, that you have to check. Okay, and that we have to calculate by, again they are given by using first method ultimate creep strain and by using creep coefficient method. Okay, so we will have the given data first according to the solution of problem. Okay, so we will have the given data here first. Okay, so now they are given as a concrete section that is rectangular, 100 mm wide by 300 mm deep. Then they are given the area of pre-stress, that is 5 wires of 7 mm dia, 5 wires of 7 mm dia. So it will be, we will get 192.42 mm square. We will get 192.42 mm square. Okay. Then they are given the initial stress Pi as 1200 Newton per mm square. The initial stress, that is Pi is equal to 1200 Newton per mm square, and the eccentricity is also given as 50 mm. These are all the given data. Okay. Then the area of concrete is 100 by 300, so that is 3 mm square, 3 into 10 to 4 mm square. Okay. Then also I, that is BDQ by 12, because we require this for the calculation of stresses. Okay, so we will get that is 225 to 10 to 6 mm raised to 4. Okay. So according to the given area of pre-stress and initial pre-stress, we can find out the pre-stressing force. Is equal to initial pre-stress into area of pre-stress, that is initial pre-stress into area of pre-stress. So that is initial pre-stress is 1200 into area of pre-stress is 192.42, so we get it as 230.9 into 10 to 3 Newton. Okay. Yes. Then the other given data are modulus of elastic of steel is, you can take it as 210 kilonewton per mm square. Epsilon C S, which is required for the calculation, it is 41 into 10 to minus 6 Newton per mm square. Even though if it is not given, you can use code, that is IS 13431980. These values we can get from IS 13431980 if you go back and check IS 1343. Okay. Then EC, that is modulus of elasticity of concrete, is 38 kilonewton per mm square. Okay. These are the given data. So first you note down the given data. So according to ES and EC, you can calculate first. Therefore modular ratio M is equal to ES by EC. So we got it as 6 and also you can take creep coefficient phi is equal to 1.6. Creep coefficient phi is equal to 1.6. So we'll calculate now. Okay, so they are asked to calculate the loss of stress in steel due to creep by using first, that is creep coefficient method. Creep coefficient method by using creep coefficient. So which is given by loss is equal to m into fc into phi. Okay, m into fc into phi. So m is nothing but the modular ratio which we have, and phi is the creep coefficient 1.6. and what is fc? Then now fc is what again? So I think we have discussed while the stress calculation in elastic deformation of concrete. fc is stress in concrete, stress in concrete at the level of steel, stress in concrete at the level of steel, which will be given by fc is equal to p by a. This is because of direct stress, p by a, plus because we don't have movement here, so m by z will not come, so p e I into y. So where you can use y is equal to I only, because we have to find out the stress at the level of steel. So p by a into p e I by I into y. Okay, so we'll calculate that. Okay, so here p is given as we have calculated p, that is 230.9 into 10 to 3. Area of pre-stress, area of cross section plus 230 again p into 10 to 3, p into e, so that is 50 divided by I 225 into 10 to 6 again into e is because p into e divided by I into y is nothing but e here. So we got the stress is 10.2 Newton per mm square. So this is the stress in concrete at the level of steel. Okay, understood? Then so we'll calculate now one by one. So by creep coefficient method, we have the stress, loss of stress, so which is given by creep coefficient, it is given as, or yes, by creep coefficient it is given as m into, it is given as m into fc into phi. Okay, so here the modular ratio, so it is m into fc into phi. Okay, so where m is nothing but modular ratio, so we have got it is 6, and the fc is here we have got, here we have got fc as 10.2 and the phi is given as 6. Okay, so we got it is 97.2 Newton per mm square. So there is a loss of how much? 97.2 Newton per mm square. Okay, by creep coefficient method. And next one is ultimate strain by using ultimate strain. Okay, so which is given by again epsilon cs into fc into modulus of elasticity of c es. So epsilon cs is again 41 into 10 to minus 6 into 10.2, so fc is 10.2 again, into es is 210 into 10 to 3. Okay, so you will get 88 Newton per mm square. Okay, so the loss in stress, loss of stress in steel due to creep of concrete, by creep coefficient method we got 97.2 and by ultimate strain method we got 88 Newton per mm square. Okay, so this is regarding the calculation of losses due to creep of concrete, the calculation of stresses in steel due to creep of concrete. So you check once again, you have to go back, if your textbook you check you go to the code books also. Okay, you check the various values taken in the calculation, and you have to solve. And if you get any doubt, okay, you can free to ask, or you can post the queries through WhatsApp. Okay, thank you very much.